Greetings from HIMT. Today we'll discuss the basic refrigeration circuit which is there on the ships and the elements, just a brief description of the various elements in the circuits. Let us have a look at a circuit here. As you can see, we are having a basic circuit. You know the basic circuit that you would have studied in your school or college before joining a ship or before thinking about going on a ship would be a compressor, which is shown here, then a condenser, which is shown here, then you have a place where the gas expands and it comes down to a lower temperature. That is the expansion valve, which is shown as this, and the evaporator where the heat exchange or the fridge room. So in this, there are some additional elements which we need to look at. Say for compressor, it has got three safety switches around it. The most important one I would say is the oil pressure switch, which ensures that the oil is maintained in the crankcase and it lubricates the parts, the piston and other parts, so that the parts are moving freely. It's mostly a reciprocating compressor which is used on the ships. So the oil pressure will ensure that your parts are free to move and frictionless. Then the next one is the LP switch. LP switch has got multiple functions. One of the functions is to start and stop the compressor. We'll come back to that afterwards. And the other one is, if the LP pressure is very low, it should stop the compressor. That is called the LP cutout. So it is a single switch LP cutout which functions both the things. And then on the other side we have another safety on the high pressure side, which is the high pressure cutout, or if the pressure goes high, the compressor gets switched off. All these are electrically connected to the panel. After the discharge valve, we have a oil separator. Oil separator is mostly applicable for large compressors and where the oil is not miscible with the refrigerant. If the oil is miscible, then it will pass through the whole circuit and come back to the suction side after the circuit. It's a closed circuit, and it's a norm that the pressure inside the crankcase is connected to the low pressure side. That means the low pressure gas comes back and fills the crankcase, which is normally higher than the atmospheric pressure. So now let us see the oil separator. We were here. So oil separator also works out. It's a cyclone separator where the oil will be centrifuged outside, will be thrown out and collected at the bottom. A float mechanism will ensure that oil goes back into the sump at regular intervals once the oil level increases. The gas is passed through and it is cooled by seawater. Normal seawater temperature is 28 to 30 degrees. That is where it on the sea. So that is where the condenser cools the seawater and maintains the pressure based on the gas. Whatever liquid is there, it drops down into a reservoir. Reservoir may be a similar shape or it may be like this, how it is shown. Similar shape like the condenser, a cylindrical pipe, a huge pipe which is covered on both the sides. So the idea of reservoir is that only liquid should pass through to go for further circuit. After the reservoir, it goes to a filter dryer where any moisture, if it is there in the refrigerant, it is removed. It also filters out any dirt which may have come in during the compression process or the pipeline rust and all. And then it goes through a side glass. This side glass, if it is showing bubbles, it would indicate that the gas is less in the circuit, it is not coming as full liquid, or there is some air in the mixed in the refrigerant. After the side glass, it comes through a set of valves. One will be a manual valve, and the second one is the important one, that is a solenoid valve. The solenoid valve, say a room temperature has to be maintained minus 20 degrees. Say a meat room temperature has to be maintained minus 20 degrees. The solenoid valve is the one which actually tries to see the room temperature. It will sense the room temperature by a sensor. Inside there will be a sensor which is not shown here. Through the sensor, it will come to a thermostatic switch. So let us say a sensor is there, a bulb somewhere in the room where the temperature is sensed, and it will come through a switch. The switch will probably send an electrical signal to the solenoid, which will switch on or switch off the solenoid valve. So if the temperature is say minus 16 degrees, so it is not good enough. So now it should start. It will pull up the valve and allow the liquid to flow through this, and a fan will be running. Fan will cool the send cool air on top of the coils and cool it further. From minus 16 air will be sent, and it will cool down to minus 20 degrees. Once the room temperature comes to minus 20 degrees, this solenoid valve will send a signal to switch off the valve. So then the valve is switched off, and the gas will not flow through this, the liquid. Here the third one is an expansion valve, that is called a thermostatic expansion valve. This is the one which drops the pressure from say 10 bar to whatever pressure is required for the given room. The meat room pressure, say for a given refrigerant, will be around 1.0 bar, and veg room pressure for a given room of about 0 degrees or minus 5 degrees would be around 2.8 bar. So veg room pressure is normally higher than the meat room. In a refrigerant, from the Mollier chart or pH chart, we can see a higher pressure corresponds to higher temperature. We'll just have a look at the Mollier chart after this, after looking at the circuits. So then it goes through the coils, and typically coil would be similar to your if you have seen in your house, you have these circuits, the split AC circuits. You have a coil, and behind the coil a fan will be running and throwing the air into the room. So these coils will have a very low temperature liquid plus vapor. So the cooled air will be circulating through the area or the room which is getting cooled. Okay. So now this is how it happens up to here. After this, what happens is, now we spoke that this meat room is at about 1 bar pressure, and this is about 2.8 bar pressure. So what happens is, here to maintain a higher pressure, we have something called a back pressure valve. Back pressure valve will ensure that the veg room temperature is maintained high enough, say around minus 5 degrees, to cool the room to. There needs to be a differential to cool the room to minus plus 4 degrees. Then this comes out and it goes. back to the suction side. The suction side pressure will be there when the rooms are open. When the solenoid valves open the rooms, the center valve, this is the solenoid valve. So when these are open, there will be gas flowing through the circuit. When all three rooms are closed, that time the gas will stop flowing. The LP cutout will act, and due to low pressure it will stop the compressor. So this is a basic circuit, and we will try to understand a little more on the back pressure valve functioning. So the handling room and this are at 2.8 bar, and meet room is at 1 bar. Now suppose the back pressure valve was not there. There would be two problems. One is that this temperature would be down to minus 20 degrees, minus 20 or minus 25 degrees. So that would spoil the vegetables in the veg room, and it would have a lot of frosting or water removal from the air in the room. It will be difficult to maintain the vegetable in the room. Meat room is, say, suppose the second problem what we can face is, if suppose this back pressure valve is not there and the pressure here is 2.8 bar. So if it is 2.8 bar, the gas will try to find the path of least resistance. It will go and block the flow of the meat room. So you will have disturbance in the smooth flow of gas in the meat room, because gas flows from high pressure to low pressure, and hence it will disturb the functioning of veg room and meat room. I hope you have understood. If you have any doubts, you can ask in the comment section, and we'll be happy to help you out. Thank you.